I'd like to talk to you a little bit about why you would actually seal anything. People just talk about sealing without much understanding of what you want to actually achieve. And I guess as a homeowner or even as a tradesperson, an architect and so on, you can't be expected to know all the technical problems that can happen with a material and why you would seal it, what you're looking to protect against. I guess the basic thing is, here's a piece of unsealed stone, an unsealed piece of granite. And the big thing that everybody, if I said to somebody, why would you seal something, they'd probably say, oh, to stop it from staining. And that is true. It's one of the biggest concerns with a product. We're just putting a little water on here. I'll just leave it here for literally a few seconds. 1, 2, 3, 4, 5. It's enough. And now you will see there's a lovely dark patch where that water went. So oil will actually go even quicker into a material like this, and granite's actually quite a dense stone, so other stones will go in even faster, or concrete pavers or brick paving or something like that. So I guess this illustrates the main reason why you would seal things, not for staining, but because the material's porous. And porous means it's got all these little holes, all these little capillaries in it, and that liquids can go into, actually get sucked into these capillaries. So staining is one thing. Staining is actually, even though it's something that concerns people most, staining's not that big a deal because you can remove most stains. Of course, it's a pain, you don't want your surface to look horrible and all that, but if you do get a stain, it actually can be removed. So it is a good reason to seal, but it's not like crucial. I mean, if you did get a stain on the surface, you can remove it. There's some other more important reasons why you need to seal a porous material, especially, for instance, outdoors. So if you have some paving outdoors or some stone in your wall or something porous, then there's all sorts of problems that can happen from water going into the stone and causing real serious problems that you might not be able to fix. So one of the most important ones is something called efflorescence. So efflorescence, let's show you a picture quickly. So efflorescence is this white residue that you get on the top of, mainly of paving and so on. You can actually get it indoors, but it happens less. Why it happens is, if you get water getting sucked up from underneath into your paver, the water will come up, and when it reaches the top it will evaporate. And when it evaporates, anything dissolved in the water, so all the minerals in the water, will be left behind on the surface. And those are the white bits of residue that you see on the surface. Now, if those sit there for a little while, they'll actually expose to the air, they'll actually harden. And you'll get to a stage where you need to use a strong industrial acid or a machine to grind it off, and it's a real serious problem. It can cost you thousands of dollars to fix. So that's something you can definitely protect against, an important problem. And then you get something that's related to that that's even more damaging. So if you get the water going through the stone and evaporating out of it, and you get little mineral crystals being deposited inside the stone, sort of near the surface, those little crystals will grow over time as little salts, and they will start to break little pieces off the material. Yeah, we'll show you a picture of it. This is something called spalling. And the thing about spalling is, of course, it's actually you're causing physical damage to the material. That's not something you can repair. So when spalling first starts, you don't notice it. And that's the important bit. You get these tiny little particles being broken off the material that are smaller than you can see. But as those particles get broken off, bigger holes for water to move through, you get more water movement, you get more mineral buildup inside, and those holes start to get bigger and bigger, and eventually you might have whole pieces or whole flakes coming off. By then already your material is not in very good condition and probably about ready to be lifted up and replaced, which is obviously incredibly expensive. So these are definitely problems you can, and the same thing happens in a freeze-thaw environment. If it's cold and water gets into the pores of your material and it expands inside just like a mineral does, it'll expand and break little pieces off, and eventually it looks almost exactly the same. The material starts flaking off or coming off in chunks. And these are things that you can avoid by stopping the movement of water through the material. Now, these are very, very important. Now, some impregnators can help with these things on some materials and some can't.